you all. So my name is Prakash. I'm based out of Bangalore, and currently I'm working at CoinDCX. So people who have not heard about CoinDCX, just in case. So CoinDCX is a crypto exchange and DeFi platform, and I mean we have almost more than 15 million users, and our vision is to expand that and give access to for the crypto and Web3 assets to the masses. And we know that the world of crypto is little complex because a lot of regulatory and things comes in between, right? It's not just like you go and do trading on Zerodha. So a lot of things come. So we wanted to make it as simplified as possible, that so that it becomes the mainstream asset class for the masses. I mean, this company has been started by like 2 IITians back 7 years back. Has become unicorn in 2021, and it has on paper more than 2 billion valuation, but actually in reality it's way more because this is based on last funding. All right. So about me, like I have almost 20 years of IT engineering experience. Worked on different companies, like right from mostly I worked on startups. Sometimes I, for the sake of changes, have worked on enterprises also, just to understand their problem statements and how they are differ. And since last 10 years, I'm in data engineering field. So I love building large-scale data platforms, and things are evolving rapidly. But what is most important is like what thing passionate me more about is like solving the critical business problems and through data, so that it can add huge value. And of course, in my personal hobbies, I love swimming, farming, and programming. So like this activity I can do any time of the day. Yeah. So today, like I am going to cover. I mean, you people have heard a lot about like on the data. Maybe there is some overlapping, of course. But what I'm going to cover is like what are the key fundamental ingredients which we should must keep in mind. That is like I learned from my experience. Like we make a lot of mistakes, build something, and then iteratively we came to some platform, right? So what are the key ingredients for the success? And then we will deep into some architecture patterns, and then probably towards the end we will look some of the use cases which we have solved through like AI and ML, right? Okay. So next time coming to, of course, like any kind of a build definitely should start from the expectations, like what matters for the business. If we align to that thing, then it becomes very easy for us. Then whatever technical fantasy, it goes away. Like I simply say, like, and then you simply focus from the business perspective, right? So some of the key things which we look into is like, first is of course data democratizations. We know that we are in the world where it's not about one unit transformation. We are looking for all around transformation. And to give all around transformation, what is important is like to have access to insights and informations at fingertips for all your business units, including like, and how can you empower each business units to take the data-driven decisions. That is the first thing. Second thing is like, how can you add value to your product? How can you give value to your customer? Because the moment you start giving the value to your customer, you start growing, helping to grow the product way faster and give the competitive advantage. So that is super important. The next thing is like today, like everybody needs real-time action, and I'll tell you this is not something which is sort of a want, but this is more about need. If I relate to like my own industry, like if we delay in identifying, like for example, in crypto exchanges, when we list a token, new tokens keeps coming, right? So we can't just list the token. We need to do like, there is a lot of background processing which happens behind the scene before listing the token, because we need to safeguard the user's interest also. At the same time, we wanted to give the full opportunity to our user, and many times when you don't list the token on time, then you lose the opportunity, you lose the business, and many times you lose the user also. Many users comes to the platform because of certain things, right? So it's very important to act on time. Even like same time it is important to delist the token. In our world, like we need to delist also. Like if something new scenario comes, then we need to. So there is a data-driven decision always, right? So how can you make that actions as fast as possible, and that is completely depend on your data platform. Even like if somebody has access to your kind of a because we have like decentralized platform. In decentralized platform like Octo, if somebody has access to your wallet, and it's a self-custodian things, right? So then in that case, hacker can take a lot of funds away from you, right? So that is where we play a critical role. Like we have multiple defending layer, and then how do we identify fraudulent transactions in real time, etc. So many use cases where real time is super important, and not like in the crypto industry, but across. I think this is becoming a need. A competitive advantage, of course, is like data is the biggest weapon we know, and what is most important is like making data available on time with full quality, and then across. So then it becomes the competitive advantage. So that is super important. This point is also like we know that there is a huge data literacy across the unit. Like people can use the data, they understand like, okay, if I need to take that decision, they understand from their business units like what is important for them. But it is difficult to scale your engineers or business analysts to that level. Like for each person, if they require something like programming people or like somebody who writes SQL, then it becomes very difficult, right? So it's very important that if the information is available at fingertips in a way where, when the information is required, you deliver it. Like, you break that barrier, information barrier, which comes because of technology. So, that is important, self-service analytics. This is also important because all the decisions, like I took multiple examples, like when we take the real-time action. So, all these things are actually dependent on like data. Like, so whatever data you are providing, like what is the quality of data? Because you collect the data from so many different places, and you have huge responsibility before bringing the data into action. So that is this thing is super important. Then of course, like many of you might have heard, like everybody like business comes to you and you want like these features today, like that way, right? So like making a platform in a way where you can do a rapid delivery. I'm not saying everything, but like a lot of things you can do it. Like once you started building the patents over the period of time, then you can help business in rapid fashion. Cost efficiency, of course, like this is very important. Like ultimately P&L matters for the business. So we can't go crazy on the cost. Security and compliance, because being a centralized platform, this is super important for us. So now we know these are the business expectations. So now we'll move into like what are like some of the critical elements which we must have in our data platform. Many people have, I think, discussed on unified data architectures. I'll not go in much detail, but I think I mean of having is like centralized platform. Centralized in the sense like processing-wise it's distributed, but logically you see like it's centralized, so that you just need to connect to one. Like internally you have so many systems, but you just need to connect to one and get the information. Real-time data processing, as I explained, like the importance of why business is looking for. So there you have to have a place completely, like it should not be integrated in sidelines, but it should be part of your core stream where, if new use cases comes, you can plug in like, so a lot of streams are coming. Real time, maybe you don't need to act on one stream or two streams, it may be multiple streams. And then also you need the additional data to augment before taking the decisions, right? So all these things requires a proper thought process in the platform. Next is AI ML ready design. As we discussed today, like a lot of things has been discussed on AI ML, but it's very important that whatever data platform we are building is like for all round transformation. So this is a part and parcel of the game. So how do we build things which is completely usable and we can do a rapid innovation? Because one of the our responsibility is to fuel innovation in the business, so that way we can always get the competitive advantage. Of course, scalable in the sense many dimensions. Like we see the volume grows over the period of time. We see use cases grown over the period of time and it gets crazy. We see uh, so basically your number of users can grow rapidly, right? So all these dimensions you need to be scalable. You need to think about like how can you make systems super scalable. Of course, data governance is important because you have unified platform. That means like it's very important like what informations, what insights to be shared to whom, right? So that level of governance has to be there. Security has to be there, of course, because be it data, because a lot of data movement happens in the platform. So whether data is at rest, data is in motion, data is there, PII data, so many things are moving pieces, right? So how do you ensure that data is completely secure and you know that, what accesses are given, plus like enough auditing also in the system. Cost efficiency, of course, in the era of cloud, like it's very easy to go infinite scale theoretically, but ultimately it hits to your bills, right? So every places the cost efficiency is super important, because as and when like more and more data means easily your cloud will go very high. So this is, I'm just placing here a blueprint of the architecture. So basically, this can vary depending on, but fundamentally I'm just trying to say like this component should be modular. Modular, why I'm saying is like each piece, like any piece we think, because we are building the future architecture. So future is like every time it is evolving. So any piece which comes in the market, which is like, best in class, then we can easily replace it. Why to have architecture where, it should not require us to, have a lot of changes. If I need to replace, for example, here compute, storage, or like any kind of a data ingestion layer, so I can do it very easily. Like that should be the motto. If you see the architecture from left to right, so all people needs to deal with the sources. That is true. Like so, like for us also, like we need to deal with a lot of sources. For us, there are some kind of a messy and very high volume sources is also there. For example, in blockchains, when we need to get the events from blockchains, the informations are not like the way it is. Like you need to do a lot of curations before you get the information. But what I'm trying to say is like, when you start doing these things, so ultimately the number of sources over the period of time grow rapidly. What is more important is like, if you see, the patterns are fixed. If you identify key patterns, like be it like what level of interfaces it is providing, be it pull, push, what is the formats, what is the variety, what is the angle of like whether when you are getting data, let's say for example you are getting data from API, or you are getting data from some operational databases, or you are getting real-time streams. So there are well-defined patterns. So once you code for the pattern in your data ingestions, then your job is super easy. Like that is where I'm saying rapid onboarding of new use cases. So when we need to onboard use case, means we need to onboard data also many times. So when you onboard new data, your platform should support. Like so, if you see control plane there, so we should have something where we can rapidly onboard. Like for example, I need new data for my new algorithm. Okay, here this data could be external data, internal data. It could be competitor data. Anything is possible, right? Then we have something, even like at the ingestion also, you should have something which has a huge number of connectors, or like if you're doing something in-house for a specific purpose, so you should localize for that purpose. Otherwise, it becomes your innovation, I think, get limited, like in terms of like, so many places you can get the data in a matter of minutes these days. So why to miss that opportunity? Then now the middle part, if you see, the middle part is like the core heart of the system. If you see, like there are 3 layers: compute, storage, and your governance layer. So we know that we want to have decoupled storage and compute, fine. So in compute, your fundamentally you have stream processing and batch processing. When I say stream processing, it could be absolutely real time or near real time, depending on like the use cases, and then batch processing. So the point over here is like, when you, let's say new business case comes, then how efficiently you can place those use cases on this platform is very important. So like for example, is it that simple, like you go in and put new logic there and rest up, because stream processing anyway has the, consider like you build in a way that streams are coming. You can place any rules over there, and then you can get the data from your storage also, and then you can say like, okay, now after that I want to do this. So you define your sort of a source, sink, and logic, and then you can apply like, and then there are additional things which you can apply in terms of how frequently you want to do, etc. So that should be fundamentally there. Is if regarding the storage, like you see like there are multiple boxes over here, and basically over the period of time we have identified also, I mean, if one size doesn't fit all, right, so we need to have something where we can host all sort of a data. We welcome like be it coming from blockchain, structure, unstructured, at scale, like, because this is the era where we do ELT, not ETL, right? So we wanted to keep every data, and we want something like reliable, cheap storage. So that is where the lake plays the huge role, because here it's very important that you don't know, like today you want to do this processing, but tomorrow the new use case comes and you don't want to miss on the data. So data is there for everything. Then of course, like when you want to have sort of a curated information, then you want to have some sort of a warehouse where you can provide information well curated, and then to your serving layer very easily, in terms of speed, in terms of quality, everything, right? So that is where the data warehouse will play a role. Many times what we do is like lake and warehouse, we combine these two things, which is fine, but architecturally we need to know that, okay, when I say like warehouse, then what is my expectation in terms of the queries should run in that much time, it should have that quality of things of my data. It will require a lot of business modelings also, so that those kind of things will come into that. We discuss on like AI ML ready, right? So basically when we build all these things, it's very important that we use the reusability in mind. So this feature store addresses, like before this session I was listening like to build the feature store and efforts, right? So it's a part and parcel of your design. If you don't consider, then over the period of time, consider like you're training your model through some different logic, and then you are actually doing prediction through different logic, then it will bring inconsistency. So it's very important. And then across models, you see like over the period of time, you start sharing using the same features. You building sort of a feature group family and start sharing the same feature. So this brings the consistency, this brings the rapidly onboarding new systems, new services, and also it reduces the time in terms of the turnaround time, because your features are mostly ready because it's a part of your engineering itself. Then fourth thing is like like there are multiple analytics we do. Like when we see like serving layer on the right side, so we do a lot of things, not just BI, right? These days, a lot of trends are like where you do user-facing analytics. Like for example, we do like LinkedIn, Facebooks, they do, right? So how do they do it? Like, so they don't go like, so basically the challenge is very different. There, the number of users who are accessing your system is not in thousands, it's in million. So then you have to have that level of concurrency in your queries. The response time is very different. When user is waiting for something, it means you can't hang him for like even couple of seconds. Then it requires sort of a sub-second response. The information also, accuracy of the information and freshness is also super critical. So the challenges varies. That's why we need to have different systems in order to serve those kind of things. Now, the bottom layer, if you see like where we are talking about, irrespective of multiple systems, but what we are giving to the outside, this is the packaging. What we are giving to outside world is like, no, they don't need to deal with so many complexity. They have to have some sort of a catalog where you can see information, you can search information, you can discover information. There is enough context in that catalog where somebody can see like, okay, what are the information which is of mine use, right? So that is where the data catalog will give like kind of a unified catalog. Then lineage, of course, is important because you are doing a lot of transformation, a lot of streams are coming, then you are applying computations, cleansing, and all these things you are doing. So how the data has reached to a final stage, how do you see it? If some problem comes, then you can always troubleshoot, look, identify problems. So the lineage is like very important from that angle. RBAC, of course, if you wanted to apply any kind of a governance, because we are saying that this is a unified layer, you can access the data, but who can access what, you can always control through RBAC. Audit, this is like post thought in a way, like for example, if somebody is doing something with data, so every actions are being recorded, so you are doing audit. Now you can use some kind of a model to identify if there are some threats. Threats could be in any form, right? So you can, once you audit, then that is possible. So like this is the middle layer. If you see on the serving layer side, BI, we know that whatever is readily available, dashboarding, reporting, monitoring, alerting, everything is coded there. But self-service analytics, as we discussed, on the fly we can give the insights. For example, user comes, like, stakeholders comes and they wanted to see like what happens to my business, why there is a drop, why there is a like sudden sudden failures in the system. So all these things is possible, provided you provide, because for everything you can't code and create dashboard, but a lot of things where you require sort of a self-service analytics. So this plays a critical role into the ecosystem. Then data science, as we discussed, like we need to have execution environments where data science team can access the data, they can do exploration, they can experiment, they can do hypotheses, they can build the models, they can identify the features. So that kind of execution platform is required in order to get to the objective. And then once the data science team are like, they know that this is actually connecting to the business, then the next thing is like you require sort of a ML ops kind of things where you can actually productionize your model, and then you can control. There are so many challenges which comes when you productionize the model. Once after that, there is a possibility of model drift. You need to continuously evaluate the performance of the model. So all these things require a proper kind of a pipelining over there. Then reverse ETL, like for example, this data is not only for like internal information. We wanted to use this data across, like we wanted to improve our product experience, we wanted to improve our user experience. So the reverse ETL is required. So this is all about the architecture. So far, I'm taking a little bit pause, but just in case if you have any questions, we can cover, and then I'll go to the use cases further. We can cover it last also. All right, so the next is like, yeah, this thing I think I didn't thought of, like, but many people have discussed a lot on like how can, so basically data is feeding a lot to AI. Without data, AI is not possible, and vice versa. Like now AI ML is also transforming the way we are doing data engineering a lot, right? So as we discussed self-service analytics, how can we use AI ML to do a self-service analytics, which we discussed, right? We can use, these days like off-the-shelf models are available. You can use those models to actually, earlier it was very difficult when you do NLP, etc. The quality was, not at that scale. But today, how do you, basically a lot of things are connected. Like how do you organize your data, and like as I said, cataloging also is super critical. Like when, let's say you have enough context about your schema, enough context about each columns, definitions, business meanings, your whatever jargons you are using within your business, because a lot of things is related to your business. So if you have enough information, then self-service analytics is possible. Then you can build the model on top of that, and somebody asks questions and you can transform these questions into SQL, not just SQL and then provide the data, but then on top of that you can provide the reasoning in the sense, like for example, you see there is a funnel drop. Like for example, you have a customer journey starting from sign up to onboarding to making deposits to do first trade, right? So eventually that journey, so you can see like why funnel drop is happening, what is the reasons, and it can answer. You don't require analytics team to build the complete thing and find out, because it takes a lot of time, right? So that is possible, provided like how good we did the cataloging. That is where I'm saying semantic cataloging is pretty important, and AI is helping a lot in this case also. Like, so understanding, not just understanding how the column name has been given, but also you can use the AI in order to understand the data and use that to feedback, like give the enough context and semantics to your data so that your metadata layer becomes very strong. Feature of prioritization. So basically, here also AI ML is helping a lot, right? What features play a critical role? Query optimization. Like these days, like I'm sure like you people have gone through that phase. Like people are coding through AI, right? Not just coding through AI, they are also doing review through AI. Like somebody is writing query, what we see, like what is the possibility of optimizations, etc. So all these things, but it really depends, like when you are taking a model and how much let's say whether you use reg approach, whether you use prompt tuning approach, or whether you use model fine tuning approach, either of them. But how you're utilizing your data is super important. Then your answers will be correlated. So I mean that becomes pretty important. Now some of the use cases we can look. So I will cover. Okay, so I will cover one use case then quickly. So basically this is like customer chatbot. So every business has some problems, and then eventually customer, like for example, you did some deposits, right? And your deposit is not reflecting in your wallet, or you have questions like how to do some activity. So for all these things, we had a chatbot, but whatever chatbot we had was like more like flow driven, like a lot of graph. Let's say for example, different business flows and rules has been given, and then customer is going through that journey in order to find out the answers. But that chatbot had some fundamental problem. A is like discoverability, like to reach to your solutions, it takes a lot of time. Scaling agent, when some problem comes in crypto world, what happens is some failure comes, then it fails to so many users. It impacts a lot of users. Then all the users will come for the support case. Then you don't have that many human agent. It's not possible to scale human agent. That is where, how can we use AI in order to solve that problem? And then third thing is response time, of course, because human agent will take time to provide response, etc. So this kind of things was actually a problem. To solve this, we use LLM, but it's a very different journey, because we started with something, then it didn't work out, then we gave in iterative fashion, then we crack the problem, like okay, to use the LLM, what exactly we need to do it. It's not like when we say multi-agentic, like we need to, actually ultimately it's all software engineering. So you have to break down problem in a very small pieces, like scientifically. So like for example, first user comes with some problem. So you know also within your data that what user has done, what is the possible problems of users. You already know, because you have data in real time. Now user chats something, then you identify intent very quickly. It is very easy to, if let's say initially when user chats and you provide the resolutions, so that is if you try to solve a complete problem in one go, then it is very difficult. The accuracy of that model will be go on toss many times. So you need to break down that in multiple pieces. First you say like, okay, first I will identify a problem. Once you identify a problem, then you may have n number of different flows, but you then have multiple agentic approach and different models, which is specialized for that problem. And that model is like equipped with your data. Then, so basically you're going in a systematic way. So this way we try to solve it in short, like we reduce agent handover rate a lot. Like, so how do we measure our efficiencies? Like if you like 1,000 users has raised the request, how many has eventually lent to agent, human agent? Our objective is to protect our human agent and then solve the problem also. It's not like protecting human agent means like customer is not happy. So we need to measure the customer satisfaction also, and we wanted to, so that is what we were trying to achieve, and we achieved it. And this is how like, so multiple problems we have solved, like, but like just to give this. So taking a pause here and opening for question answers. Yeah.
So recently, CoinDCX has a cyber attack.
Yes.
So how CoinDCX is protecting itself against cyber attack?
Yeah. So exactly. So basically, when you are in this game, the problem could be like, as I said, like we need to identify. So basically, if somebody is actually doing crypto withdrawals, right? That's the biggest risk. So if somebody is doing crypto withdrawals, it's not like if you come to the platform and we give the crypto withdrawals like infinite. There is a systematic process, and that systematic process is based on data. So we take a lot of data. Like for example, we look for like if the customer has just arrived and then he's looking for a lot of withdrawals, we will not give it. Then, I mean, there are your transaction patterns, your trading patterns, your wallet activity patterns. We ask for certain proofs from you also. We look for risk score and full KYC. After that, all these things, what we do is like, then only we enable certain withdrawals. That is one. Second thing is our assets are like, whatever our assets are, that is like behind, would say like it's a trusted in a number of forms. Like, so basically there is a security team within the CoinDCX. altogether a separate department, and any kind of a code or designs which goes through that. So any kind of things will has to cross through them, and then a lot of tools in place which protect. So basically, you've seen that that is the biggest trust factor which should have on this kind of platform.
So what is the mistake that Vajirex has done? Like that's why like hacker was able to get all the withdrawals.
Yeah. So basically there was a I mean, they did a malicious attacks in order to identify like potential leak in the wallets where they keep the fund, right? And it was like systematic thing happened like for the couple of times, right? So basically they first identify the loopholes by actually putting I would say like it's a combination of multiple things. Like so when the excess of the system has happened, and once they know the key part of assets, right? Then they started withdrawing it. So basically, it's a sort of a open. I mean, not one thing. Their assets are not secured in a way like whatever keys, etc. Because in world of blockchain, you know that everything is like dependent on your keys, how you are protecting those keys, where you are keeping those keys, etc. Right? So they have access to that keys, and that is how they withdraw all the money.